Hello everyone. So in this tutorial I'm going to show you how to draw a linear regression for data visualization using Python and other tools like Matplotlib and SciPy. So the first thing you are going to do is that you are going to import Matplotlib. So we're just going to write import Matplotlib. So after importing Matplotlib, we are going to use Matplotlib for data visualization. So after that, we are going to import SciPy. SciPy is a Python package that enables us to plot a linear regression. So we are actually going to import SciPy, and to do that, we are going to say from SciPy. And in this case, we are going to use stats because stats is the module that contains what we need for drawing simple linear regression. So we are going to say from SciPy import stats. So after importing stats is now when that we are going to define our data. Like we are going to define our data in form of x and y axis. Like for example, x is equals to, let's say, 1, 2, 3, 4, 5, like that. So for me, I had copied the data, so I'm just going to paste there. So like that. Okay, so after defining your data for the x-axis and the y-axis, now the next thing is that we are going to actually create a function, and a function in Python that is actually going to help us to come up with the y-axis. And so this function, let's say we are going to call it define plot. Let's say we are just going to call it define plot, and inside the function we are going to pass an argument x. Okay, this argument x is actually what is going to help us to come up with the y is equals to mx plus c. That is what we are trying to come up with. Then we are going to return, we are actually going to return the slope times x, times that value of x that we have returned as an argument, plus the intercept. This simply shows that y is equals to mx plus c. It shows that if you have the value of x and you have the intercept, then you can actually get y. Okay, so we are going to return it plus the intercept. After doing that, then we are going to initialize some variables here that is actually going to help us to come up with the linear regression. So we are just going to say the slope intercept r, which is the coefficient of correlation, which measures the relationship between x and y, and 0 means a bad relationship while 1 is a good relationship because it is always in -1, 0 to 1. Then the p, which is the probability of the data being correct, and the standard error, which is just stder. Okay, so after doing that, we are going to equate them to stats which we had imported earlier on. These stats that we had imported earlier on. So we are going to equate them to stats.linRegress, and this is how we initialize the linear regression. Okay, so we are going to just say start.linRegress, and we are going to pass the data, the parameters for x and y axis. So we are just going to pass x and the y axis. So after passing x and y axis, we are now going to initialize the y axis. Like we are going to initialize now our data, and to do that, we are just going to say my data, for example, and is equals to list map, meaning we are going to actually map function is actually used to loop between the x-axis arrays, so that we can now plot the y-axis on their own. So we are going to list map the plot, and inside there we are actually going to pass x because we are list mapping this plot here. So we are going to list map it with the value x. Okay, so after doing that, we are now going to plot it. So we are just going to say plt.plot, and after saying plt.plot, we are going to plot the x. This now will help us to now visualize the linear regression, the x, and then the data here that we have come up with there. So we are going to do plt.plot x with my data. Okay, so after doing plt.plot x with my data, then is now when we can now show it. So we can do plt.show. Okay, and that is how we've done our linear regression, so that
If we now run it, it is now going to bring us the table or the chart of the linear regression. Sorry, I forgot one thing. I forgot to add this scatter plot. So because scatter plot is used to actually visualize the dots, okay, so we are going to add plt dot scatter, and we are going to pass the parameters, which is x and y axis. Okay, so we're going to pass x and y axis, and if I run it again, you can now see the scatter plots there. Okay, so this is how we can now visualize the data using linear regression. We can see the residual points, which is actually the distance from the dot to the line. That is called the residual points. And to see if this is a good fit or this is a bad data, we can actually find the coefficient of correlation. We can just print the coefficient of correlation and the probability of the data being good. So we can just print R, and we can just print P. Okay, so when we print R and P, R is going to give us the coefficient of correlation, and P is going to give us the probability of the data being accurate. So we can see that the coefficient of the correlation is negative 0.7, which is okay. Actually, it is not a bad data, and the probability of the data being okay is actually 0.0022 something. So it is not that bad data set. So this is how you can draw linear regression in Python. Very simple like this. Thank you.